You ever wonder how scientists can look at a fossil and just know it's 65 million years old? Or how a doctor knows exactly when a drug has cleared your system? Well, it turns out they often use this surprisingly simple rule of thumb to solve what's called the 99.9% problem. And trust me, once you get it, you'll start seeing it everywhere.
So here's the big question, right? How do you time something you can't even see? Think about it. There's no stopwatch for when a drug's effect finally wears off, or for when a single radioactive atom decides to decay. These things don't have a clean stop button. They just kind of fade away. But it turns out nature actually has a predictable, built-in clock for all of these fading processes. It's like a universal countdown that lets us measure and predict them with amazing accuracy. And it all boils down to one single predictable pattern. And that pattern looks a lot like this. Things like radioactive decay don't just come to a screeching halt. No, they fade out along this predictable curve. See how it drops off a cliff at the beginning, and then the process slows down and flattens out over time? That shape is the secret sauce, and it's all governed by a very simple, very powerful idea. And that predictable curve is all about a concept you've probably heard of before, the half-life. It's a simple name, but it is an incredibly powerful idea. So, what is a half-life, really? It's super straightforward. It's just the time it takes for a substance to get down to exactly half of what you started with. It could be the caffeine in your morning coffee or the carbon-14 inside a dinosaur bone. For any specific substance, that time period is always the same. Let's make this super clear with a pizza. Okay, so after one half-life passes, you've eaten half, so you've got 50% left. Now, after a second half-life, you eat half of what's still there, which leaves you with 25%. After a third, you're down to 12.5%. Get it? You never technically finish the whole pizza. You just keep taking half of whatever's left.
And that little pizza example shows off the most important, and honestly, the trickiest part of this whole concept. The half-life is constant. It does not matter if you start with a mountain of something or just a tiny speck of it. The time it takes for half of it to disappear is always the same.
Okay, so we've got a handle on half-life. Now let's put it to work. We're going to use this simple rule to finally crack open this 99.9% problem. So here's the puzzle. We know it takes one half-life for 50% of something to go away. The question is, how many half-lives does it take to get rid of almost all of it, to be 99.9% complete? And it's not as easy as just doubling the time, right? Because of that whole pizza thing, that exponential decay. The key to the whole thing is hiding inside a specific formula from chemistry. Don't worry, we're not going to get lost in the weeds. Just think of this formula as the mathematical blueprint for that feeding curve we saw earlier. It's the tool that's going to give us our answer. All right, let's look at the numbers. It's really just a simple two-step calculation, and the result is so satisfying. Okay, first up, the formula compares our starting point, a full 100%. To the tiny little bit that's left over when we're 99.9% done. And that leftover amount is just 0.1%. So 100 divided by 0.1 gives us a nice, clean 1,000. This number basically represents the scale of the change. Now for the cool part. So how does the formula deal with a big number like 1,000? Well, it uses a clever mathematical tool called a logarithm. All you need to know is that its job is to tame that wild exponential curve and turn that big number into something much simpler. And in this case, the logarithm of 1,000 is simply 3. That's it. That's the key number we've been looking for. Now, let's put it all together. If you run that same formula for a regular half-life, when 50% is gone, you get a value of about 0.3. But for our 99.9% problem, we just found the number is 3. So wait a minute. You see that, right? 0.3 and 3. That is not a coincidence. And this isn't just some neat math trick. This simple relationship between 0.3 and 3 reveals an incredibly powerful rule of thumb that scientists and engineers use all the time. And here it is, the punchline. Because that number 3 is 10 times bigger than 0.3, it means the time it takes for a reaction to be 99.9% done is almost exactly 10 times its half-life. That's it. That is the solution to our problem. This chart just makes it crystal clear. Let's say the half-life of caffeine in your system is about 1 hour. That's the small bar. Well, using our new rule, we know it will take roughly 10 hours, 10 times as long, for it to be 99.9% gone from your body. It's a fantastic mental shortcut.
And this is for way more than just caffeine. This simple 10 by rule is absolutely critical everywhere. It helps archaeologists carbon date a fossil. It helps doctors figure out the right dosage for life-saving medicine. It helps engineers safely manage nuclear materials. You name it. It's basically one of nature's fundamental countdown timers.
It really gets you thinking, doesn't it? We just uncovered this elegant, simple rule of thumb that was hiding inside some pretty complicated-looking math. What other simple, hidden countdowns are out there, quietly running our world, just waiting for us to find them?